Hello everyone, welcome to the R Masterclass lecture 3. In this lecture, we are going to look at the mathematical notation and string used in R language. So you might be wondering what mathematical notation we are going to look at. We are going to look at the addition, subtraction, multiplication, division. Then we are going to look at some complex equation which might contain sine, cosine, log. And then we are going to look at how you could do this onto the complex number and what does complex number means. It's basically of the form of a plus ib, where I is the imaginary number. And then we are going to look at how you could define vectors. Then we are going to look at how you could define characters, and then eventually move on to the strings. So what is the aim of this lecture? First aim of this lecture is you to get familiarized how you could use our command console. Next aim of the course is you to understand how our language and grammar works in R. Basically, by the end of this lecture, you will be having a good grasp how you could read and write in R language. And last one, throughout the lecture, if you don't understand what mathematical equation is, you don't need to worry about the mathematical equation. Basically, you need to understand how the code works in R and what is the diagram we are going to use in this lecture. Before moving on to the R console, we should have a mental map that how does our language runs into the machine. So basically, we have our source code. It goes into the compiler and it checks for if there is any error or mistake, and if there's any error, the compiler will throw out the error that you have. This error, you might be missing some semicolon or some undefined language, or you might be having some issue on the code. It will throw error. If not, this will convert into the bytecode. Basically, machine understand 1 and 0, and this would be converted into that language, basically low level language, that is into the 1 and 0, which is understandable by machines, and then it could be easily interpreted by Windows or Linux or Mac OS. That's how a compiler or source code is converted into machine code when you compile the code. Now we have got the mental understanding that how does our compiler works. Now let's open our R console. So now let's look at how you could use mathematical notation in R console. So you have to start with the R console, not with the R studio. Basically, R console is very beginner friendly if you want to start with. So basically, if you want to add two numbers, you need to have a plus operators, and you could add two numbers like 2 plus, get into the console, 2 plus 3, and you will get your answer. Similarly, you could do for subtraction, we could do 5 minus 6, and here we get our answer. We could do similarly for multiplication, 7 into 8, and you get your answer, and you could do division as well. So now we have got an idea how to use simple mathematical calculation. Now let's look at some complex mathematical equation which contains sine, cosine, tangent, log, can be used in our language. So basically, we don't need to remember any other syntax. We need to know how to use help function. Basically, we are humans, and you don't need to learn remember all these commands. Basically, you need to know how to use help. So if you need to know how to use sine, so just use help sine, and it will open the documentation where you could go through how to use sine, and below you have examples that how you could run this. So basically, if you need a sine to run, so suppose if we want to get sine pi, and we could write sine pi, we could get the value of this. So the value accepted in this trigonometric function is accepted as radian. So suppose if you want to calculate for the degree, we remember in our maths class that if we need to convert any radian into degree, we just need to multiply that number by 2 pi by 360, and we will get our value in degree. So suppose we need to calculate for sine pi. Suppose here we get the value for the sine pi, and suppose we need to calculate it for sine 45. So we multiplied it by sine 45 into 2 into pi, and we divided by 360 degree. So here we get the value for the 45 degree angle. So here is a task assignment for you. Basically, you need to calculate the value of this equation. You could pause this video right now and try to calculate by yourself. And now we will try to calculate the value of this equation. So first, let us look at the equation first. So we have 3 plus e to the power square, then divided by cos pi. So we have some exponential function, and to use an exponential function, let us clear our console first, and then we look at how you could use the exponential function. So to use exponential function, we could basically call help. Okay, we look through the documentation first, and we could look at here that we need to provide the parameter x to the exponential function to calculate it. Now we have got the idea, okay, how to use the exponential function. Now let us calculate the value. So we have 3 plus addition, and then we have exponential, which we provide, we are doing the square, so square, and we then divide this whole thing by cos pi. So we know how to use cos. We just need to provide the value and then pi, and then we get the value minus 10.38906. Now let us clear our console. To clear our console, we remember that Control L is the shortcut key, and now we will look at some miscellaneous examples, such as if you need to calculate log. So currently log is if you calculate log 10, the base is e, so it will it's a natural log, so it will calculate the value of log to the base e. And if you need to calculate log to the base 10, you could calculate easily by log to the base 10 divided by 10. So here's the value should be the 1. And similarly, you could calculate exponent for value 2.7184. We could also calculate constant value 3.14, and here we could also look at some miscellaneous example of trigonometric function, such as cos pi. Here we get the value minus 1, because cos pi, that is 180, is minus 1. Here we could also look at tan, and here we get the value minus infinity. Here we get the value tan pi is the smallest negative integer, that is minus infinity, that the R language could hold. Now we will look at how you could use assign operator in R. So let us clear our console. So before looking at how you could assign the value to the variable, we should know what variable is. Basically, variables are used to store values. So where it is stored, basically in RAM, it is stored at random position. So here we could know that the variable 1 is stored at something 2000 position at the RAM. And basically we don't need to worry about where it is stored. Basically we need to know what variable are and what is used it for. And now we have understand what variable is and what variable store their value at. We could now look at how to define assign value to the variable. So first, let's declare a variable name, let's say vec, and we assign value to it using a backward operator. We assign value to any variable using backward operator, and let's assign any integer value such as 2, and here if we print vec, and here we get the value. Now let's do some addition programming. So let's create another variable, let's say vector 2, and assign its value using a backward operator like 8, and then we do a addition operation. So vector plus vector 2, and you get the value 10. Similarly, you could do multiplication, you could do subtraction, and similarly you could do the division. You could use it with also like other trigonometric function we have learned about, and logarithmic function that we know. So let's say log vec, and we will get some value based on the natural log. Similarly, we could do for sine, and we get the value. Now we have learned about what variable is, how to use a sine operator. Now let's look at some miscellaneous examples. So now let's look at some miscellaneous example that we are going to look at. First, we are going to look at how you could declare multiple variables at once. So let's say we want to declare vector 1, we could assign those value, backward operator, vector 2, similarly backward operator, vector 3, and we assign a value to this as a 0. So here, if you look at this expression in the R, you might get confused, but you don't need to. Basically, we are declaring variable 1, vector 1, vector 2, vec 3. We are assigning the value 0. So if you print vec 1, and close the parenthesis, you will get the value. Now, there are multiple ways that you can declare variables in R, but these are highly discouraged and should not be used in R language. And basically, for the knowledge we are going to look at. So you could directly use a sine operator to declare assign the value. So if you want to do this, the R compiler will not throw error because it's accepted in the R language, but it is highly discouraged in R. We could also do one forward operator and vec. What do you think? Will it throw error? No, it's all okay with our compiler. Basically, we shouldn't use this. It's highly discouraged in R language. So now let's look vectors in R. Basically, vector is collection of similar type. So what does types mean here? Basically, the data types that are integer, float, double, string, character. And now let's look how does vectors are defined. So basically, in R, here is a vector defined and it contains the value. And basically, it's a collection of similar data types. As you can see here, that the data type is moving from 10 to 100, and the index, if you are coming from Python or any other language, you might seem very intimidated that here the index starts from 1 rather than from 0. So you should keep in mind that index in R starts from 1. So here you could see that index for 10, the value is stored in the array of index 1. So if we need to access this array and if we need to get this value, we need to go through the index 1. Similarly, if we need to get the value of 20, we need to get to the index 2. Similarly, for 3, we will get the value 30. Similarly, for 40, we need to access the value 4. So how you could create a vector in R? So now let's open our console and clear our console, and let's define a vector 1 and let's assign a backward operator. And to define the value in vector, there is a C method, like, which is meant for concatenate the variable. So we will use 10, 20, 30 and enter. And if we print vec1, we get the value or vector. So what if we need to access the value 1? Access the value 10. So we need know that the index starts from 1. So we'll go to the index 1 and here is our value. Let's do for 30 vector 3 is at position 3 and here vector 1 which we have defined and that the position is 3. So here we get the value. We could similarly do addition, subtraction in this vector. So let's declare another vector 2 and add some values 40, 50 and 60. We have added concatenated 3 variables. So here is a typo you need to look at. So you need to declare C, which is used to concatenate the integers. Now we have declared the value. You could print the value when you add. So let's say you need to add vector 1 plus vector 2. So let's see what will be the value would be. It's 50, 70, 90. So basically it's adding the vector based on the index. So 10 is added to 40, which is 50, and then 20 is added to 50, which is at index 2. Both are added, and then the value is 70. And similarly 30 plus 60 is 90. Now we could do similarly subtraction. We could similarly do multiplication and so on. Now let's look at some miscellaneous examples. So let me open our console and here let's clear our console. So first thing, what if we need to declare a variable with empty values? So how you could declare it? Basically you could declare it by vector and then backward operator, and then we have a method that is known as numeric, which will initialize the vector with value 0. So if we print vec, we'll get the value numeric value 0. And what if, let's say we have vector 1 of values, let's say 1, 2, 3. We have vector 2, backward operator, value 4, 5, 6. So here is a typo. We forget to concatenate at the C method. So vector 2, 4, 5, 6. Now, so how you could append those vector 1 and vector 2. So one method could be to use directly C method and concatenate vector 1 and vector 2, and here you could get the values. Other method could be used to, if you need a much more manual method, you could use append. And here you have the value appended from vector 1 to vector 2. So you might be wondering why to use append if we could use concatenate. Basically, append provides you much more ability to control the vectors. So here, if we look at the help for the append, you could look at that it accepts 3 parameters, that is x, that which the vector is, then the values, it could be the other vector, and the after which index we need to concatenate. So now let's look at the example. So suppose we need to append vector 1. So we called append. We need to append vector 1 with vector 2 after index is 2. After 2. So here we are appending the vector 1 with vector 2 after index 2. So here after index 2 we are appending the value of vector 2. So vector after vector 1, 1, 2, which we have the index 2, and then we append the vector 2, which is value 4, 5, 6, and then the rest of the value vector 1, that is 3. Okay, so suppose we need to calculate the value, we need to calculate the length of vector 1. So how you could calculate it? So the general method is you need to call length method and you get the length. Suppose you need to declare vector of length 10 initialized with value 0. So how you could do that? To do that, you could easily use numeric. So numeric, and then we assign a length is equal to 10. So 10, and we get the array initialized with value 0 with length 10. Now let's look at how you could define complex number in R and do mathematical operation in R such as addition, subtraction and multiplication. So before we go on to R, basically we need to know what is a complex number. Basically a complex number is in the form of C is equal to A plus IB, where I is the complex imaginary number. And similarly, you could define another complex number, C2 is equal to A1 plus IB1. And here, if you need to make an addition, if you want to do like make an addition, C1 plus C2, basically you could do A plus A1, and similarly I plus B plus B1. And similarly here you could do the subtraction. So subtraction would be C1 minus C2 would be A minus A1 minus I B minus B1. And now it's time to look at how you could do this in R. First we will open our terminal, clear our console. Let us define a variable. Let's declare our variable 1 with takes method complex real is equal to 7, imaginary equal to 10, and then we similarly define variable 2, and we could do the addition. And here we get the value. Now it's time to look at the strings and characters in R. So if you have come from C++ language, the way to define character is like you need to define a data type char and then variable name, and then in single quote you have to define the characters. So in single quote it could be A or any other characters, but the length of the word should be a 1. So basically you could define any word, but any character, and that character length should be the 1. And what if you define AB? The compiler will throw error in C++ language that will say that char cannot accept multiple characters. It could accept only one character, so the B needs to be removed from here, making it a single character. Now in R, here we don't have any problem such like that. We can define it in single quote or in multiple quote. So let's open our console. We remove the clear our console. We define a character ABC and character ABC in double quotes. And we so let's find character, and here we have a typo character 2, and then we compare character 1 compared to cat 2. What would be the value? Will it return true or it will return false? Let's see. It will return true. As we could see, both values are same. Now let's see what if we need to get the number of characters in a string. So for this we have a method called endChar, and in this we could give any string and it will return the number of character in that letter. Okay, now next task is, so suppose here let us define a variable temp and we assign a value to it to be hello world, and now we need to access only the world word. So now our task is to get the word world from the hello world string. So we know a method that is known as substring, and basically the first parameter it accepts as the string that we need to do the operation on. Then it accepts the parameter start, which needs an index to where to start from. So we know the index starts from 1, 1, 2, 3, 4, 5, then space is 6 and world is 7. And from 7 to word 8th, 9th, L would be 10th and D would be the 10th. And then we substring the word. Basically this needs to be the 11th word to the 11th word. So 7th, 8th, 9th, 10th and D is 11th. Basically a typo. And here we get the word. So let us create a new variable. Let us say temp2, and here we assign the word today is Sunday. And now it's your task assignment to get the word today from the string temp2. How would you do this operation? So if you could, now you could pause this and try to attempt your own, and once you are done you could automatically resume the lecture. So to that we could use substring method and we pass the temp2 string. We start from 1 to the word stop. So we start from 1, then O would be second, D would be third, A would be fourth and Y would be the 5th. So till 5th, and we get the value today. So with this we could wrap up this lecture and I will see you on to the next lecture. Thank you everyone.